वेपर, आप बताओ व्हाट इज वाटर वेपर? एटमॉस्फेयर में द मॉइस्चर दैट इज प्रेजेंट इन द एटमॉस्फेयर, ठीक है, इन सिंपल टर्म्स, दैट इज कॉल्ड वाटर वेपर ऑल्सो, and in terms of, in other terms, it is called humidity. Now this humidity, the moisture which is present in this atmosphere, can be measured through two different ways. ठीक है, this water vapor, what I'll do it, I'll call this as humidity, right? Now this humidity can be measured in absolute and relative. One is absolute humidity, other one is relative humidity. And yesterday I have given you the definitions that absolute humidity is the total amount of moisture which is present in the atmosphere, which is measured in what terms? It is which is measured in weight. मतलब क्या है weight? ठीक है? This is measured in terms of weight. And this weight is measured in such a way, I told you, that you take one cubic meter. ठीक है, imagine this is 1 cubic meter, each side is 1 meter. In this box, what is the weight of that moisture? ठीक है, which is measured in grams. इसीलिए grams per cubic meter कहा जाता है. This is what is grams per cubic meter. Do you have any doubt in this? You're clear with this. Now coming to the relative humidity. ठीक है, relative is always with respect to a benchmark. ठीक है, कोई ना कोई बेंचमार्क होता है. फॉर एग्जाम्पल यू सी परसेंटाइल सिस्टम पता है आपको? इन योर कॉलेज इज परसेंटेज गिवन और परसेंटाइल गिवन? नहीं है, नहीं, दोनों सेम नहीं होता. परसेंटाइल, कैट एग्जाम सबने दिया होगा, कॉम्पिटेटिव एग्जामिनेशन, उसमें दो चीजें होते हैं. जैसे देखो, एक परसेंटेज होता है, एक परसेंटाइल होता है. ठीक है, परसेंटेज और परसेंटाइल में द फंडामेंटल डिफरेंस इज परसेंटेज इज कैलकुलेटेड फॉर ए पर्टिकुलर मार्क्स. फॉर एग्जाम्पल, द टोटल मार्क्स इन योर ग्रेजुएशन, इट कुड इन योर स्कूलिंग, इट इज फॉर 500 मार्क्स. जस्ट इमेजिन, आउट ऑफ 500 मार्क्स, इफ यू आर गेटिंग 300 मार्क्स, व्हाट इज द परसेंटेज? हाँ, बताओ ना. 60%. ठीक है, to make this little more simple, what I'm doing is I'm trying to bring out an analogy. With that analogy, I'll explain you this. Imagine that the total marks are 500, and for this 500, what I've done is, you got 300 marks. Now what is the percentage? 60%. ठीक है, if suppose I'll consider this is measured in percentage. When it comes to percentile, ठीक है, it will be like this. Suppose another person who got 300 marks, what is the percentage here? Same, 60. But in percentile system, what do? Is they'll declare this person as rank 1, and this 300 marks are 100%. ठीक है, for example, this is percentage system and this is percentile. Suppose another fellow got maybe 295. What is the percentage? 59%. Right? If suppose another person who have got here 295, see, percentile system is calculated like this. This 300 who got, which will be equivalent to 100%, right? He'll be declared as 100 percentile, right? Now, 295 marks is how much percentage of 300? Percentile system ऐसे calculate किया जाता है. The first ranker, whosoever is declared, whosoever is the one, will be declared as 100 percentile. Now from his marks, rest of the people marks will be declared. Now this is the fundamental difference between percentage and percentile. ठीक है? Now just remember this. Usually, your relative humidity is something which is declared on the basis of percentage. कैसे? फॉर एग्जाम्पल ये जो परसेंटेज, दिस इज वेट, दो अलग अलग चीजें, डू नॉट मिक्स विद दिस. नाउ yesterday आई टोल्ड यू दैट इमेजिन देयर इज अ पैकेट ऑफ एयर. ठीक है, लेट्स इमेजिन दिस इज अ ग्लास and if I close this gas, there is a packet of air in this. Now if suppose in this glass there is 20% of moisture. Okay? What I'll do is, this glass, there I said 20% of moisture is in there in this, right? So for you to make it little more easier, I'll make small units in this glass. ठीक है, छोटे छोटे units बनाया. I'll call, see here, this part of the glass is filled with moisture. Maybe that is 20% मान के चलो. ठीक है. First, suppose if I am increasing the temperature, what I have done, I have increased the temperature. Imagine this is 20 degrees Celsius. Now when I increase the temperature, usually in the size of the glass क्या होगा? Increase होगा, right? So what I'll do is I'll increase the size of the glass. Right? What happened to the carrying capacity of this glass? Carrying capacity क्या हुआ? Increase हुआ, right? Surface कुछ बता रहे हो क्या? हाँ, basically if you increase anything, their surface area increases. ठीक है, be it your human body or anything you heat in the atmosphere, that you heat something, it will expand. ठीक है, that is what is some fundamental logic. Now look here, 20% of moisture, if I bring this 20% of moisture here, what happened? Is it the same moisture? This 20% which you have in this glass is 20% for this 100%. But if I am bringing this, imagine relatively humidity क्या हुआ? Decrease हुआ ना? If I am increasing the temperature, the size of the glass increased. In simple terms, instead of this glass, I am going to expand the air. Imagine instead of this glass, think as the air. Relatively, humidity is less here. Moisture क्यों expand करेगा? Moisture तब भी बढ़ेगा जब evaporation हो रहा है. ठीक है? Suppose instead of this glass, imagine this is an air packet. When I'm giving more heat, the glass will expand. ठीक है? The carrying capacity of the glass increases, or else the carrying capacity of the moisture increases. Right? The moisture is same. The moisture present is same, but the carrying capacity increases. Now just understand the same analogy if I'm decreasing the temperature. ठीक है? So imagine this temperature which I have told you, here it is 20. I'll call this as 30 degrees Celsius. But if I'm going to I'll reduce this temperature to 8 degrees Celsius, or maybe for your convenience I'll convert this into 12 degrees Celsius. What happened to the size of the air packet? Shrinkage. Just imagine the size of the air packet is shrinked, right? So here, this is the total amount of the moisture that is present here. Now this moisture, when you come and fit in, what is the humidity here? Relative humidity बताओ. Relatively, if you are decreasing the temperature, अभी ऐसा लग रहा है ना इस ग्लास में बहुत ज्यादा मॉइस्चर है. ठीक है? If you are increasing the temperature, relatively the humidity is reducing. ठीक है? If I am decreasing the temperature, relatively my humidity is increasing. ठीक है? Relative humidity is always measured at a given temperature. At a given temperature. Now, I'll reduce couple of more degrees Celsius temperature. This is 12 degrees, right? From 12, I'll take this to 10 degrees Celsius. What happens to the size of the packet of the air? Or shrink होगा. This would be the packet of the air size. Now, if I'm bringing this moisture here, so for our convenience, I'll full this. That means entire packet of air is now filled with moisture. अब क्या होगा? Now what next? If I am reducing 1 more degree Celsius, what happens? Saturation. ठीक है? If I am reducing 1 more degree Celsius temperature, the air is 100% saturated. Right? Now here air is 20% saturated. Here the air could be more or less saturated. But this air is 100% saturated. When you have 100% saturated, what does it happen? It will rain. ठीक है? If suppose I am reducing 1 more degree by 10, I'll make it to 9 degrees Celsius. Now the packet of air will be smaller. So as soon as this air is completely full, this will start to give rain. अब ये जो टेम्परेचर है, this temperature is called as dew point. Now what is a dew point? Yes? When the air is 100% saturated, the temperature at which that saturation happens is called a dew point. Now this is called as a saturated air. The temperature at which the 100% saturation takes place is called as dew point. Dew point is a temperature. Absolute humidity is measured in weight. Relative humidity is always measured in percentage. ठीक है? समझ गया? Clear? Okay. Now before we go any further, let's move to our topic. Yesterday we were discussing about, last topic was नोट्स दिया था मैंने. चलो आज हम क्लाउड्स पे चलते. Today we will be discussing about clouds in very detail, and every year if you look into, there are few questions that are asked from the clouds topic, right? So देखो atmosphere area में ना examiner is asking one or the other question, especially in the clouds area. Last 2 years there are few questions on the clouds. First, before we go into this topic, I wanted to ask you, what is a cloud? What is a cloud? रोज देखते हो, ठीक है? अलग अलग शेप में होता है, अलग अलग साइज में होता है, एंड डिफरेंट कलर्स ऑल्सो इट इज देयर. बट वॉट इज दैट क्लाउड? हाउ डू यू डिफाइन इट? वाटर वेपर, ठीक है. देयर इज वाटर वेपर. व्हेन यू हीट योर चाय, वाटर वेपर इज ऑल्सो कमिंग अप. विल यू कॉल दैट एज अ क्लाउड? नो. देन what is a cloud? If your visibility is blocked, you can also sit that side. Okay. What is a cloud? A mixture of water vapor and dust particles. Very good. This is a better definition. Next, is it only water vapor and dust particles? Aerosols and what else? Can there be ice? Ice crystals? Yes, it is made up of ice crystals. Cloud is a collection of hygroscopic nuclei. ऐसा लग रहा है ना, कहीं तो सुना है ये वर्ड. आई हैव इंट्रोड्यूस्ड दिस वर्ड, द वर्ड hygroscopic nuclei, couple of days back. Now these hygroscopic nuclei are small dust particles which has charge with them. Now they cannot be seen with your naked eye, right? So clouds are nothing but a collection of hygroscopic nuclei plus which are also charged. Okay? Usually they are charged particles which cannot be seen with the naked eye. Now around this you will find the moisture. Sometimes this moisture can have a temperature less than 0 degrees Celsius. Then this moisture will turn into ice. So we have learned in yesterday's class and day before yesterday's class that what would be the temperature at 7 kilometers high? If the ground level surface temperature is 30 degrees Celsius. ठीक है? At a ground level, irrespective of the height, I am telling the ground level temperature is 30 degrees Celsius. Now, what will be the temperature at 7 kilometers height? Ground level pe it is 30 degrees Celsius. I am asking at a height of 7 kilometers, what is the temperature? If for every 1 kilometer, if your temperature is reducing by 6.5 degrees Celsius, ideally. Yes? Yes? -30 minus 45.5. What is it? Minus 15.5. Here the temperature will be. Do you agree? या कुछ मैथ गलत किया? सही है ना? My CSAT is good. You have to check your CSAT. ठीक है? हाँ. Yes, very good. See, the temperature here, it will be minus 15.5. Now, when you look into the clouds which are there, the clouds are present at 3 kilometers height also, 4 kilometers also, 5 also, 7 also, 10 also. You go to Mount Everest, the height of the Mount Everest is 8848 kilometers. Imagine this is your Mount Everest. Now this Mount Everest is 8.8 kilometers height. Sometimes there are clouds which are there. These clouds, they come and they hit with the Mount Everest. Any tall mountains. Some mountains in Shimla, they are at a height of 2000 meters. Now the clouds which are present there, what would be the temperature of these clouds? The clouds temperatures are extremely cold. Now what is the temperature? Minus 15 degrees Celsius. फिर आप मेरे से ये पूछ सकते हो, you can ask me, sir, are these clouds not made up of ice? Literally they are made up of ice. ठीक है? Now you can ask me, sir, if there is an aeroplane that is going, won't that aeroplane go and hit that ice? See, the ice is very crystallized, small, soft ice. It is not a thick ice. ठीक है? That is not a very thick ice. If that ice is so thick, under the influence of gravity it falls. Basically, it has moisture there. Right? In a collective environment, that cloud which is there, it keeps on moving from one place to another place. Now, why does that cloud move from one place to another place? Just because it wanted to release or maintain a temperature balance. Anything in the atmosphere, if it is moving, it is primarily because they wanted to maintain a balance. Because at one place there is good amount of heat present and at another place there is less temperature present. They wanted to maintain an equilibrium. That is the fundamental purpose of the moving of the wind, movement of the clouds, anything that is moving in the atmosphere naturally in the environment. Right? So broadly, hygroscopic nucleus plus moisture together, sometimes the dust particles and all of this together, they will be called as a cloud. ठीक है? कैसे? Imagine this is a small hygroscopic nuclei. Around this, the moisture, as it has charge, water is a very good conductor of the charge, right? It will start to accumulate. Now this is one hygroscopic nuclei. Likewise, you have, imagine this are hygroscopic nuclei. Now around these hygroscopic nuclei, the water starts to form, right? So in this manner, the formation of the clouds form, right? So here, if the closer the hygroscopic nucleus, and the warmer the temperature of the cloud, if closer the hygroscopic nucleus and warmer the temperature of this cloud, they have the more potential to hold more moisture. Okay? Simple, you need to remember one thing. If the air temperature is higher, they can hold more moisture. Okay? If the air temperature is lower, they cannot hold any more moisture. Remember this. I am repeating it again. If the air temperature is more, the air can withhold and actually it has more capacity to hold moisture. If the air temperature is lowered, it can not hold any more moisture. Right? So broadly speaking, now imagine collectively these things, they become a cloud. Now this cloud has different shapes. It can be present at a lower height, it can be present at a higher height. Any cloud which is heavier, it is usually present at a lower height. Any cloud which is lighter, it is present at a higher height. Right? Now there are some characteristics for those clouds which are present at the lower height and those clouds which are present at the higher height. Right? Now based on the height of the presence of the cloud, the temperature, the appearance, as well as the characteristics, the clouds are broadly classified into 4 different types. In your NCERT, you might have found that the clouds are cirrus, cumulus, nimbus, stratus. This is the generalistic classification of the clouds, but the combination of these clouds will create more number of clouds. ठीक है? Cirrus सबसे ऊपर होगा, कहाँ पर? 7 किलोमीटर की ऊंचाई पर, around 7 kilometers and above. Cumulus, it is also present at the lower end, it is also present at the higher end. Usually, this cloud is the one which will give you thunderstorms. And the vertical extent means from Zameen se higher atmosphere, the vertical extent of this cloud is more. Whereas nimbus, this has the potential to rain. It is a heavier cloud because it has more moisture. And nimbus clouds are not present at greater heights. They are present at a lower heights. Stratus clouds, they are rarefied. Layer दिखता है, stratified. So, we'll look into each of these cloud and the combination of the clouds which are present. But first, quickly write down the definition of the cloud. Cloud is a mass of multiple droplets. Cloud is a mass of multiple droplets or tiny crystals of ice formed by the water vapor in a free air, formed by the water vapor in a free air. ठीक है? Which are formed at a higher elevation. Which are formed at a higher elevation. Now, to be called as a cloud, the droplets जो होता है ना, these droplets, they need to have a size. ठीक है? The Indian Meteorological Department and World Meteorological Department, they wanted to classify a cloud, they wanted to give a literal definition of the cloud. Now, what is the percentage of the clouds which are having high, is it having more cover, is it having less cover? So for that, what they have done is, they have given a symbol, right? Thus, symbols are given like this. Suppose they fill the circles, and in this circle, what do they do is, the circle is divided into 8 parts. ठीक है? Out of this, they'll say 1/8, 2/8, 4/8, 6/8. And if suppose similar kinds of clouds are present at various places, and you join a line which is joining all these similar clouds, now that line is called as isonips. ठीक है? Isonips मतलब clouds with similar characteristics present on the atmosphere. I'll dictate, don't worry. Now, come back. To be called as a cloud, write down, to be called as a cloud, the tiny droplets of water vapor, to be called as a cloud, the tiny droplets of water vapor, which are too small to fall as a rain or a snow, which are too small to be fall as a rain or a snow, bracket में लिखो, less than 0.001 centimeters, write in the bracket, less than 0.001 centimeters or approximately 0.0005 inches in radius. 0.30 and 5 inch radius. Close the bracket. Will be suspended in the air. Will be suspended in the air. And they float as clouds. Will be suspended in the air and they float as the clouds. Write down the next point or next subheading, that the classification of clouds is based on a combination of, the classification of clouds is based on the combination of height, appearance. The classification of clouds is based on the combination of height, appearance, form, FORM, form. Based on this, the clouds are classified as cirrus, cumulus, nimbus, stratus. Cirrus, cumulus, nimbus, and stratus. In other way, what you do is, you have written like this, right? Or higher clouds, medium clouds, and lower clouds. And clouds with greater vertical extent. Right? So broadly, these are how the clouds, these are the ways in which the clouds are classified. Right? Now look at this diagram. This gives you a very good understanding about the formation of the clouds. These are water vapor. Okay? This water vapor which is present, this is nothing but your humidity, right? Now this humidity, if you have a charged particle called dust. Now this dust particle, if it is having charged, then it is called as hygroscopic nuclei. Now this hygroscopic nuclei, this is one hygroscopic nuclei. Around that, the water vapor binds it. Now like that collection of this water vapor binding or hygroscopic nuclei binded, you will call it as a cloud. Now to be called as a cloud, what should be the size of a droplet? It is 0.01 centimeters or less radius hona chahiye, right? Or else 0.005 or less inches ka radius hona chahiye, then you will call it as a cloud, right? Now these clouds, as I already told, they are broadly classified into a cloud like this. This is called as, you might have seen, very cirrus, this is called as cirrus cloud, looks like a feather. This indicates very clear weather. This indicates that the weather is quite clear. Now what will be the temperature of this cloud? Very, very cold temperatures. See, sometimes if you are living in a mountainous area, these cirrus clouds, if there's a mountain here, the cirrus clouds comes and it hits the mountain. So in fact, whenever these clouds come and hit the mountain, it does not rain there, it directly snows there. Okay? Clear? This is cirrus cloud, feathery. You might have seen this. Cumulus. Cumulus ka literal shabd, the literal meaning of cumulus is nothing but cotton ball. Cotton. ये cotton wool जैसा दिख रहा है ना, cotton ball of cotton. So this is called as cumulus. Now these clouds also indicates a clear weather. Cumulus clouds also indicates a clear weather. But these clouds has the potential to block the incoming solar radiation. What is that? They have comparatively little higher albedo. Okay? I'll tell what is albedo and other things in the next half an hour or so, but you should be clear with this. Next, don't you see in these clouds there are layers present? This is called stratus. If the clouds are stratified, this is called as stratus. Look here, kale badal, ghane badal, black color. Now you call this cloud as nimbus. Nimbus clouds are the one which has the potential to rain. Now, nimbus clouds, if they are having the more potential to rain, that it indicates that it has more moisture. The packet of air is comparatively full. That is why it is about to rain. Right? As soon as you decrease the temperature by 1 or 2 more degrees Celsius, it will start to rain. Right? See, usually, most of the times, I'm telling most of the times, whenever it rains, the temperature gets colder. It is an indication that the clouds which are there, the temperatures are getting colder. Right? So, this is a cloud which is looking like a cumulus. It looks like a cumulus, but it is having characteristics of nimbus also. Now, you will call it as cumulonimbus. Now, this cumulonimbus cloud, it has an updraft and it has a downdraft. That means basically cumulonimbus clouds are formed because of a process called convection. Okay, convection is a process where the heat is being transferred the heat is being transferred on a continuous basis and the air is continuously uplifted above and above. Right? So, in that case, you will find this cloud and they are very dangerous clouds. Aeroplanes, they won't like to go near these clouds. You know, it will thunder, sometimes it will burst, sometimes it can have heavy material within inside, and if aeroplane goes, it will start to turbulate. Turbulence hota hai. Right? So, this is a perfect image of cumulonimbus cloud. Thunderstorm vertical extent jo hai na, vertical extent can go up to tropopause tak ja sakta hai ye. What is the height of a tropopause? 18 kilometers near to the equator and 8 kilometers near to the polar region. So this particular cloud can go up to a height of 6 kilometers, 10 kilometers unchai also. So I myself had an opportunity to witness this particular cloud in an aeroplane. So I would like to show it to you. This recent visit to Hyderabad, as this is a cloudy day. So look here, these clouds are nothing but the cumulonimbus clouds. Look here, these cumulonimbus clouds from vertical extent. The flight is traveling at a cruising altitude of 30,000 feet, which is almost at 10 kilometers height. Look at this. This is a cumulonimbus cloud. Now this cumulonimbus cloud, aeroplanes will not go nearby that cloud. They simply take an avoidance. Right? This is monsoon season, pre-monsoon season. If you ever get an opportunity to travel in India through an airline, you'll definitely see one or the other cumulonimbus cloud in the plateau regions. Okay? So this is a cumulonimbus cloud. From the surface, it has evolved very well. And cumulonimbus clouds, I'll explain in little more detail when I'll teach you what is convection. Because the concept of updraft and downdraft you need to know. Updraft means because of extensive heat that the ground has. If the ground is having more amount of heat, the heat is released into the atmosphere and continuously the air rises, right? As the air rises, the heat is again transferred to various layers of the atmosphere. So, as and when the air temperature is increased, you will literally see that the potential of the air moisture, the potential of the air to hold more moisture, it will be there, right? So, in a similar manner, if there is good amount of updraft, it will easily create a thunderstorm. That is cumulonimbus cloud. So broadly speaking, these are the different types of clouds. So let's discuss each and every cloud. And there are some exceptional clouds that you will get to see. Look here. Lower clouds. There's a lower clouds. Lower clouds can be stratus. Basically stratus clouds. Right? Middle clouds are also called as alto clouds, ALTO, right? And higher clouds are cirrus, right? But there is one cloud which has a vertical extent almost up till 10,000 meters also. That is nothing but cumulonimbus cloud. Now this cloud is called as a cloud with greater vertical extent. Now here I have to explain you the characteristics of those that are present in the higher heights and those that are present in the lower heights. So you tell me, a cloud which is present in the higher heights, will it block the incoming solar radiation? Insolation, sunlight. Incoming solar radiation matlab sunlight. Yes? Or a lower cloud will block the incoming solar radiation? Comparatively. Dekho, I'll answer that question, but in a net, imagine an earth with the cloud, an earth without a cloud. Who will have more temperature? An earth without cloud. See, an earth without cloud will have more temperature. An earth with the cloud will have less temperature. Clouds have dual role. Clouds can block the incoming solar radiation, and at the same time, cloud can trap the outgoing terrestrial radiation also. For that, let me draw a diagram and show it to you. See, this is the real time. I'm showing you the satellite image of India currently. See, currently, this is India. This is somewhere our India is there. Okay, this is itself is India. Just a minute. Can you see? This is the Southeast Asia. वहाँ पे रात हो गया. We are yet to face the night. What is the time? It is 6 p.m. The sun is going to set now. As the earth rotates from west to east. See here, as the earth rotates from... Now, if I am zooming in, this is nothing but a representation of the globe. But what I am showing you here is the real-time data of the Himawari satellite, which is present on the Earth, on our face. It is a Japanese satellite. So, here can you see some light? This light is nothing but it's the twilight. Currently, India is experiencing the twilight. Right? India, the Earth always moves from west to east. Now, here you see, as soon as the Earth comes in this direction, it enters into darkness. But what I wanted to tell you here is, look at the cloud cover which is present here. This good, very good cloud cover. Tomorrow, as soon as I start the class, remind me to show the cloud cover. There is a decent cloud cover which is present here. I've seen in the morning, there is an alert for the cyclone as well. ठीक है? What is this color? Yellow. What is this color? What is this color? ठीक है, you don't have color blindness. जिसको color blindness है ना, for them they cannot differentiate what is red color, what is blue color. ठीक है, यहाँ पे lightly you can see the cloud cover, but tomorrow I'll show it to you. Don't worry. So imagine that there is good amount of cloud cover which is present on the earth. Let's imagine these are the clouds. Right? Now, and this is your sun. You have two set of clouds. One is higher cloud and other one is lower cloud. For our understanding, what I'll do is I'll draw two different clouds. These clouds are higher clouds. ठीक है? And they are lower clouds. Now what are lower clouds? Stratus and nimbus. Okay? Cumulus can be present at the lower level also, higher level also. Higher clouds are considered to be cirrus. I'll call this as cirrus clouds. Right? Now you need to know the relationship between the clouds and the insolation. That is, the sun rays which is coming, they can easily pass through this cloud. Right? But this sun rays, when it reaches the surface of the lower clouds, they will reflect back. Clouds have two properties. One, it is reflecting back, but some amount of the heat will also be transferred to the earth. Now earth got heated. What kind of waves will the earth generate now? It will generate long wave terrestrial radiation. Now what is this called? Incoming solar radiation, which is short wave in nature. These are short waves, and once the earth is heated, earth will also generate long wave radiation. Now see here, there are dust particles. Dust particles can get heated. Water vapor, what kind of a gas it is? Is water vapor a greenhouse gas? Yes? Greenhouse gases mein one of the primary natural gas is nothing but your water vapor. Water vapor is a greenhouse entity. Right? This cloud which is there, who is having more water vapor? Lower clouds. Now these clouds, what do is, they also trap the heat. Clouds are having dual properties. Number one, higher clouds which are there, they will simply let the incoming solar radiation to come. Right? But lower clouds, they reflect some amount of the radiation, and here some amount of the radiation is passed, but once the earth is heated, earth will start to send out outgoing terrestrial radiations, that is this radiation. Now this lower clouds will start to trap the heat. Right? In a net, agar dekha jaya, you have this side of the earth is having clouds, this side of the earth is not having clouds. Imagine this part of the area is also exposed to a sun. Now this will be comparatively hot and this will be comparatively cool. This part of the earth is comparatively cool. Now what I mean to say is that clouds have dual properties. One, it can heat the earth, it can trap the heat. Other one, it can reflect. But more or less, if you look into, it is the lower clouds are actually reflecting more amount of sunlight, because of which they are able to maintain the coolness in the lower atmosphere. Yes? They are very thin. So that actually albedo, her question is that she said, sir, the clouds which are present at the higher atmosphere, they are very thin. Now her logic is very right. Anything that is thin, the sunlight easily passes through them. But remember here, the albedo capacity, albedo means the ability to reflect back. The albedo capacity of the higher clouds is more as compared to the lower clouds. Let me repeat it. The albedo capacity of the higher clouds is more as compared to the lower clouds. Okay? Albedo capacity I'm talking about. See here. Let me take a hygroscopic nuclei of a higher. This is the hygroscopic nuclei of a higher cloud, and this is the hygroscopic nuclei of a lower cloud. I know this is a little confusing, but let me give you the clarity here. So imagine this is hygroscopic nuclei of higher cloud, and this is lower cloud. Right? If equivalent amount of sunlight is given to both of this can reflect easily, but this will not reflect at the same capacity. But as you already know, the higher clouds which are there, they are placed at far away. The transparency is more in the higher clouds, but in the lower clouds, right? अब बताओ, यू गॉट द लॉजिक व्हाट है? हाँ, ये डेंसिटी ज्यादा है इसीलिए इट इज एबल टू ब्लॉक द इनकमिंग सोलर रेडिएशन एंड रिफ्लेक्ट बैक. ठीक है, इसका डेंसिटी कम है तो दैट्स वाई फ्रॉम दिस क्लाउड्स देयर कैन बी सन रेज इजिली पासिंग इन. बट इन लिटरल टर्म्स, अगर एब्सोल्यूट टर्म्स में देखा जाए, इसका पोटेंशियल ज्यादा है एल्बिडो का. इफ यू मेक दिस पर्टिकुलर हायर क्लाउड वेरी थिक, मेक द हायर क्लाउड थिकर, दे विल रिफ्लेक्ट मोर. इसका थिकनेस ज्यादा है इसीलिए इट इज एबल टू पास दैट सनलाइट एंड लेट दैट सनलाइट पास थ्रू इट. राइट? सो हायर क्लाउड्स विल नॉट रिफ्लेक्ट, मतलब हायर क्लाउड्स जो है ना, दे जनरली let the sunlight pass through them, and lower clouds they reflect the sunlight. Right? These are the two characteristics that you need to know about the higher clouds. But in a net factor, if you are looking into, the net factor is the clouds always have the cooling capacity more. Though clouds are having both heating and cooling capacity, net factor cooling capacity is more. Remember this very, very clearly. The examiner can get into these areas. Okay. So broadly speaking, now this is an easy peasy game from here on. See, cumulus clouds, they are cotton shaped, right? It can be present here. The same cumulus clouds which are present in the nimbus format. Nimbus is black color, that is called as cumulonimbus, which is having a vertical extent. Higher clouds, they are named as cirrus. If cirrus cloud has layers, that is nothing but cirrostratus. If cirrus cloud is having small cotton जैसा shape, it is called as cirrocumulus. Middle clouds, they are called as alto clouds. Altostratus भी हो सकता है. Alto cloud can have layers. Alto can have small cotton ball जैसा. They are called as altocumulus. Lower clouds, basically it is nimbus. Nimbus, which is black in nature, it has the potential to rain. Right? Now these are the different types of clouds that you have. They are present at various heights. Broadly, our lower clouds which are there, they can reflect back, and at the same time, once the ground is heated, they also absorb the long wave terrestrial radiation and they reflect incoming solar radiation, that is insolation. So this is how it is. You can take photographs. Now quickly write down ISO NEPHS, ISONEPS. First give a definition as ISONEPS. What is ISONEPS? On a map, write down, on a map, if the places with equal degree of cloudiness, on a map, if the places with equal degree of cloudiness are joined. On a map, if equal degree of cloudiness are joined, that line is called ISONEP. That line is called ISONEP. So first one, give a heading as cirrus clouds. Or else high clouds. पहले high clouds लिखो. Within the high clouds, write down as cirrus clouds. Munendra, notes upload नहीं हुआ है. I'll make the notes uploaded. Don't worry, you'll get the printed notes also for this. But I always believe in the class running notes, and आपको जो समझ में आया, आप notes में कैसे लिख रहे हो, right? That is what is more important. Printed notes will be given, but I always recommend NCERT first and then next. Whatever you want to read the other books. Right? High clouds mein first cirrus clouds. They are formed at a height of 8 to 12,000 meters. 8,000 to 12,000 meters. They are formed at a height of 8,000 to 12,000 meters. They are thin, detached clouds. They are thin, detached clouds. having feathery appearance. Thin detached clouds having feathery appearance. They always appear white in color. They always appear white in color. Fair weather and brilliant sunsets can be seen through these clouds. Fair weather and brilliant sunsets. Fair weather and brilliant sunsets can be seen through these clouds. These clouds are also called as mare's tails. M-A-R-E-S T-A-I-L-S. Mare's tails. M-A-R-E-S. Mare's. T-A-I-L-S. Mare's tails. Mare's tails. T-A-I-L-S. Tail. Punch. Next cloud within the high clouds itself, cirrocumulus. Cumulus मतलब ये है ना, if at that height small clouds which are globular masses जैसा अगर ऐसा दिखने लगा, then they are called as cirrus clouds. Write down. This appears as white globular masses. This appears as white globular masses forming ripples. White globular masses. M-A-S-S-E-S. Forming ripples. R-I-P-P-L-E-S. Next, cirrostratus. They look like thin white sheet of veil. They look like thin white sheet of veil. And the sky looks milky. They look like thin white sheet of veil. V-E-I-L. Veil मतलब समझते हो ना? Something which is put on the face, that is called veil. Thin white sheet of veil, and the sky looks milky. And the sky looks milky. Next, give a heading as medium clouds. They are also called as alto, A-L-T-O, alto. They are present at a height of 7,000 to 12,000 meters. They are present at a height of 7,000 to 12,000 meters. They are present at 7,000 to 12,000 meters. First one, altocumulus. First one is altocumulus. It appears woolly. It appears woolly. W-O-O-L-Y, woolly, comma. Bumpy clouds. Arranged in layers. It appears woolly, comma, bumpy clouds, which are arranged in layers. Next, they indicate fine weather. Next one, altostratus. Altostratus. They are comparatively denser. They are comparatively denser to altocumulus. They are comparatively denser to altocumulus. Looks grayish white. Looks grayish white with a watery look. Looks grayish white with a watery look. The sun rays can faintly shine through this. The sun rays can faintly shine through this. Faintly shine through this. The sun rays can faintly shine through this. Next heading, lower clouds. Right on. They are mainly stratus or sheet clouds. They are mainly stratus or sheet clouds. They are mainly stratus and sheet clouds below the height of 7,000 feet. Below the height of 7,000 feet. First one, stratocumulus. Rough, bumpy clouds. These are rough, bumpy clouds with waves. With rough, bumpy clouds. Look at this. They are rough, bumpy clouds with waves and has good potential to rain. These clouds have contrast between the bright side and the shaded part. These clouds has the contrast between the bright side and the shaded side. Bright side and the shaded side. See, stratocumulus clouds mein na, the lower part of the cloud is little dark and the higher part of the cloud is little white. Why? Because as the moisture is little heavy, much of the moisture is accumulated in the lower part. ठीक है? And it is in the form, मतलब इसके अंदर वो potential होता है rain करने का. ठीक है? Always it rains from the bottom, so that's why it looks dark at the lower end and little white at the higher end. Stratus clouds. Next one, nimbostratus. They are dark, dull clouds. Nimbostratus. They are dark, dull clouds, clearly layered, and are also called as rain clouds. Clearly layered and also called as rain clouds. And they give continuous rain. ठीक है? Next, give a heading as stratus clouds. They are very low clouds. Uniformly gray and thick. They are very low clouds, uniformly gray and thick. Appear like a low ceiling. Reduces the visibility. This reduces the visibility of the aircrafts. This cloud reduces the visibility of aircrafts and thus dangerous to aviation. Next, give a subheading as clouds with greater vertical extent. First one, cumulus. Cumulus clouds have horizontal base with rounded top. Cumulus clouds have horizontal base with rounded top. They are formed fundamentally because of convectional currents. They are usually white globular masses. But at the time of sunset, they may look gray. See, I have made you to write at the time of sunset, right? It's not, write it as at the time of sun, under the influence of sun. It is not sunset, just strike down the set. Okay? At the time of sun, I mean to say that under the influence of the sun, it looks gray in nature. But if it is not under the influence of the sun, it looks whitish in color. Next is cumulonimbus. And remember one more thing, cumulus clouds, they do not indicate disturbed weather. They indicate a fair weather. Cumulus clouds indicates a fair weather. Only cumulus. Fair and clear weather. Cumulonimbus clouds are overgrown clouds. Cumulonimbus clouds are overgrown clouds which can extend from 2000 meters to 10,000 meters. Which can extend from 2000 meters to 10,000 meters. Which can extend from 2000 meters to 10,000 meters. Usually these clouds are formed on a daily basis at equatorial region. Usually these clouds are formed on a daily basis at equatorial region because of strong convectional currents. Yes? I'll explain what is convectional current in the further class. Right? So it has an updraft. These clouds can have an updraft and downdraft. And they have the potential to thunder. Quickly take this diagram. Fast. I'll give you 2 minutes. Done. Done? Good. Now we shall write about the difference between the higher clouds and lower clouds with respect to the insolation. So make sure to put some star marks and write this, because the questions will come from this particular sentences which I am going to dictate you. Right? Mostly the examiner interest area is this particular line. Right? Point by point likho. Lower clouds are thick clouds comparatively. Lower clouds are thick clouds comparatively. And they primarily reflect the incoming solar radiation. And they primarily reflect the incoming solar radiation and cool the surface of the earth. And cool the surface of the earth. And cool the surface of the earth. Next point. High clouds are thin clouds comparatively. They primarily transit the incoming solar radiation. They primarily transit the incoming solar radiation. Transit मतलब let them pass. ठीक है? At the same time, they also trap. At the same time, they also trap some of the outgoing infrared terrestrial radiation, some of the outgoing infrared terrestrial radiation emitted by the earth. And these clouds radiate it back, and these clouds radiate it back downward, thereby warming the surface of the earth, and thereby warming the surface of the earth. Thereby warming the surface of the earth. Did you understand what you have written? Ek baar, take 20 to 30 seconds and read what you have written and try to comprehend it. Infrared terrestrial radiation emitted by the earth is outgoing terrestrial radiation. Earth, see, what is the total? His question is that he asked me a question that सर इंफ्रारेड पहुंच जाते हैं अर्थ पे. We have learnt yesterday one thing. If sunlight is sending you the sun's rays, what is the composition of this sun's rays? What percentage बताओ, कल हमने डिस्कस किया था. Yes, 7 is UV, 43 is, 49 is infrared. So the earth which is there, if this is your sun is sending you the rays, right? And if you learn the heat budget of the earth, you will understand that this sun will send 100 units. Out of this 100 units, 35 are reflected back even before the rays are reached to the earth. And 65 units which are there, they'll try to come and reach the earth. In that, only 51 are successful to come and reach the earth. So once this 51 units come and reach the earth gets heated. When the earth gets heated, the radiation which is going out, earth will also send similar kind of rays. It will also send you infrared. It will also give you visible light. How balance kar deta hai. This is the topic which we'll learn after 5 minutes. Okay? So do you understood what you have written? Next. Whether a given cloud will heat or cool the earth, it depends upon. Write down. Next point. Whether a given cloud will heat or cool the surface of the earth. Whether a given cloud will heat or cool the surface of the earth. It depends upon several factors. It depends upon several factors. Including the cloud's altitude, comma, its size and the makeup of the particles, its size and the makeup of the particles that form the cloud. Next point. The balance between the cooling and warming of the cooling and the warming of the matliko, cooling and warming actions of the cloud. The balance between cooling and warming actions of the cloud is very close. Although overall, the effect of cooling is more as compared to heating. Right? As compared to heating. Now this is the characteristics of the clouds. The next topic that we need to learn is the heat budget of the earth. Okay? Now you will get the clarity. Okay. Naveen has too many doubts. Before that, okay, one more last cloud is there. See, sometimes what happens is that near to the polar region, you will see different set of clouds. Imagine this cloud. कभी रात को ना अलग अलग कलरफुल क्लाउड्स देखने के लिए मिलता है नियर टू द पोलर रीजन. ठीक है. In few seasons, at night time, you will get to see some noctilucent clouds, which are blue in color and reflection is too high. It is primarily because imagine you are standing on the other side of the earth and the sun is here. Sun reflects the clouds. This is night time. You are on the night side of the earth. Okay? And this is the day side of the earth. Can this happen? Where it will happen? It will happen near to the polar regions itself. Right? 6 months of darkness. So during the dark time, night time, you will see this beautiful light clouds. And these clouds will give you light onto the dark side. So these type of clouds are called as noctilucent clouds. क्या? हाँ, light का reflect हो रहा है बस. Noctilucent clouds. I'll explain about these clouds in little more detail in the further topics, not here. After I explain you what are jet streams, what are polar vortex, in the next 3 days or 4 days I'll be there. That is when I'll discuss about this particular phenomena in detail. So sometimes the aeroplanes will avoid all of these clouds. Okay? They are very cold, all of a sudden they'll change the temperature, and also they'll sometimes fall as a ice. These clouds, immediately they can gain some kind of heat, and they'll do abnormal activities near to the polar region. Okay? So those people who are living here, they don't know that this is the phenomena, and they start to pray to the mystical things. Right? So this is how ऐसे दिखता है, and they call it as a god. ठीक है? So our gods are nothing but the interactions of these rays. These are called as noctilucent clouds, and quickly the definition is on the board, take it down. Noctilucent clouds are illuminated by the sun. Noctilucent clouds are illuminated by the sun long after it has set. Long after it has set at the ground level. Long after the sun has set at the ground level. We see them as blue-white swirls, curls, tendrils shining. These are words that the appearances that they look. ठीक है? Curls जैसा, tendrils जैसा, या swirls. रात को चमकते रहते हैं, तो इसीलिए they are called as noctilucent. Done? Yes. Anirudh Mudai question is that, sir, apparent movement of the sun will also change? Yes. Apparent movement will, sun of position will always change. See, this is polar region, right? In the polar region, you know that the earth also rotates, right? When the earth rotates, this person will always be in the darkness, right? So apparent movement of the sun is that today sun is here, after some time the sun will be here, because the earth is rotating. After some time the sun can be here. So it is the earth that is rotating, and this person, irrespective of its rotation, he'll never come into the light side. We have learned this 4 days before, the position of the sun and the earth in detail. Okay. Now, what we'll do is we'll next move towards another topic. Just a minute. That is heat budget. ठीक है? What is the average temperature of the Earth's atmosphere? Why only 15? Why only 15? Why not 10? Why not 12? Why not 16? Why not 20? Why are we fearing for that 17.5 degrees Celsius by the end of 2100? He says that, sir, carbon dioxide we are increasing through industrialization process, and carbon dioxide is a greenhouse gas and it is trapping the heat. That's why we fear for the 17.5 degrees Celsius, right? So we are fearful for the change in the temperature of the earth. But our understanding should, my question here is, why is this earth having only 15 degrees Celsius of its temperature average? Why not 15, 16, 17, why not 16, 17, 20? Sun is the oldest lamp. How old is this lamp? Billions of years, right? Earth is its baby. You know that Earth also came from the sun, right? Now this Earth is able to maintain 15 degrees Celsius, not just now, from almost lakhs and lakhs of years. Why this temperature is not changing? It is only the human, after industrialization process, we have tweaked it. But you need to understand this 15 degrees Celsius the Earth is able to maintain because of the concept called heat budget of the Earth. See, the temperature of the Earth was always constant. I am telling was, not is. We are changing it. It is because whatever the amount of heat that is received by the sun, which is sent by the sun and received by the Earth, is sent back again into the space. Now this process is called as heat budget, right? Budget, jitna aa raha hai, utna hum वापस बेच रहे हैं. That's why our Earth is able to maintain this 15 degrees Celsius. But to understand this, you need to know a process called what is conduction, what is convection, what is radiation. The heat on the Earth is distributed through 3 different processes. Conduction, convection, radiation. Heat transfers are taking place through conduction, convection, radiation, and the fourth one is advection also, you can say. Right? Now first is convection. First is conduction. I wanted to show you a small slide here. The sun rays that is coming from, the heat that is coming from the sun is coming in the form of radiation. Now what is that? Incoming solar radiation. Outgoing terrestrial radiation. Right? So radiation is a process which is done through sun also. It is also the work of the earth. So because of this radiation, the heat is transferred. See, the sun is never in contact with the earth. Earth is never in contact with the sun. But still, the heat of the sun is able to reach the earth without any contact between each other. Now this process is called as radiation. Right? On the other side, if the ground is able to heat the immediate air in contact with the earth, that is because of conduction. In simple terms, I have given you an example in the previous classes also. Imagine this board is so hot, and if I am able to touch this board, and the heat of the board is transferred to my body because I have touched this board. That means a bodily contact should be there. If there is a heat that is being transferred through contact, that is called as conduction. Now the third process is called as convection. What do you mean by this convection? Convection is when heat is transferred to a certain layer, the entire layer will be lifted up and the lower layer will start to get heated. Okay? So continuously the heat is being transferred to each of these layers and then they are able to maintain that heat. Now that process is called as convection. To explain this in little more detail, let me give you a small analogy. Imagine the sun rays are being sent on continuously to this part of the surface. Okay? Continuous sunlight is there. Now what happens to this part of the surface? It will start to get heated. Right? Now once this part of the layer, you immediately what do you see is that this lower part of the surface is getting heated. Now once this is heated, in the convectional process, it will shift upward because anything that gets heated, it will start to rise. Air that is heated will start to rise. Now it will be hot. And the next layer which is there, it is again heated because continuous supply of heat is there here. Now through that, this is heated, so this will rise up. Next, another layer will start to get heat. So after that, it will rise up. Now like this, the heat is being given continuously. Supply of heat is there continuously. So let's simplify this diagram. The air continuously rises. Yes, cyclone formation के लिए potential है, ठीक है? But cyclone formation needs 5 different conditions. Tropical cyclone always forms in the sea. If this is happening on the sea, it can be potential cyclone. Next, that needs a Coriolis force. ठीक है? A temperature of 27 degrees Celsius on the sea. If these conditions are there, this will turn out to be a cyclone, right? But I'm talking on the land. So land पे क्या है? It is tornado, नहीं? Tornado is different thing. But continuous heating is happening. Imagine there is water body present here. The water vapor is continuously heating, and then they are rising up. So once it rises, the air starts to move outward. Now why it wants to move outward? This is 0 kilometers. This is 13 kilometers. Because you have troposphere का highest part है, right? Topmost part. So this way, if the heat is being transferred from one layer to another layer, this is called convection. And एक और चीज, you should not be confused with this, that radiation will happen at one place, conduction will happen only at this place, convection will happen at that place. No. All the 3 processes can take place in one single place also. ठीक है? Right? For example, let's look into this room. AC. AC actually does, you कभी सुना होगा convectional AC? आजकल नया एड्स आ रहा है ना, कन्वेक्शनल एसी करके बोल रहा है, ठीक है? कन्वेक्शनल एसी मतलब, कन्वेक्शनल एसी का कॉन्सेप्ट ये है ना, इट इज दिस कॉन्सेप्ट. You will also have conductional AC. Conductional AC is nothing but the air, whatever the air that comes in contact with that body, it will get cooled. There are 2 different types of ACs. Now likewise, you see, at one single place, you can see all the 3 processes taking place. It's not that यहाँ पे conduction ही हो रहा है, यहाँ पे convection नहीं हो रहा है. Sometimes the convection can overpower, sometimes the radiation can overpower, sometimes the conduction can overpower. It's like that. So broadly, these are the 3 steps that takes place in transfer of the heat, right? So with this understanding, what we'll do is we'll go back and try to understand the heat budget of the earth. Heat budget of the earth simply says that the total amount of the heat that is sent by the sun is again sent back by the earth back to the space. So how is it done, and how is earth being able to maintain that temperature? Let's try to understand. Now for this, let's try to understand that, imagine this is your sun. And if sun is sending you 100 units, so what I'll do is I'll classify the entire heat of the sun into 100 units, right? Now this 100 units of the sun, when they are sent onto the earth, see, earth has clouds, earth has dust particles, earth also has certain other kinds of atmosphere. You know about the gases. There is carbon dioxide, there's methane. Every gas is there. Earth's atmosphere. Atmosphere is a collection of dust particles, water vapor, gases, and also clouds. So, here, 35 units are actually reflected back into the space, even before they are reached onto the surface of the earth. ठीक है? 35 units are reflected back into the space even before they are reached onto the earth. Now, how are they being reflected? Here, you will see that 2 units are by snow. ठीक है? Next, clouds and atmosphere. So broadly 35 units, atmosphere is 6 units. (27 units are reflected back through clouds and 6 through atmosphere. Right. Now, how many units are left? 65, right? Now, this 65 units which are there, these 65 units while they are traveling, even before they are reached onto the surface of the earth again, here, (14 units बाकी जो 65 यूनिट्स है, so what I'll do is to make it little more easier, (65) should come onto the earth, but 65 will not come and reach. Out of this 65, 14 units are being absorbed by the atmosphere, right? नवीन ने पूछा था, सर ये क्लाउड्स हीट absorb नहीं करता है क्या? Clouds will also absorb. That 14 units are actually absorbed by the clouds. Clouds have dual properties. They can reflect back and they can also trap the heat. Now, what are we talking about? These are incoming solar radiations. Insolations, no. 14 units of the incoming solar radiations are being absorbed by atmosphere. Now, how many units are coming and reaching the earth? Very good. It is 51. So this 51 units which have now reached the earth, all the 51 units will be sent back again. Now how are they sent back? This is something which you need to understand. Right? Anyone who would like to try how they are sent back? Yes. See, once the earth is heated, what kind of radiation is sent back? So this is outgoing terrestrial radiation. क्योंकि अर्थ इज हीटेड नाउ. In this 17 units which are there, (17 units are sent back to the space. Now rest, how many are left? Out of 51, 17 is gone. 30? How? 46? 34, no? Right? It is 51 minus 17, how much? Confident hai? Pakka? Very good. So rest of the 34 units, (6, 9 and 19). They are divided into 6, 9 and 19. Right? What is 6, 9 and 19? See, basically 6 units are sent back to the atmosphere directly again. They are absorbed by the atmosphere. 34 units are left, right? In this 34 units which are sent back by the earth, in this 6 units are being absorbed by our atmosphere. ठीक है? और क्या क्या हो सकता है हमारा एटमॉस्फेयर में? Where else they can be absorbed? I'm telling this 34 units which are there, they are absorbed within the Earth's atmosphere itself. Clouds भी हो सकता है. Next. Plants take some amount of heat. Valid, but the amount of heat that plants take from the surface of the earth is very less. In fact, latent heat of condensation. Latent heat of condensation. Can anyone tell me what do you mean by latent heat of condensation? Yes. Out of this 19 units which are there, कल ही तो लिखा था ना आपने. Yes, say it loud. Yes, she has defined it right, but let me make it simple for you. For example, evaporation होने के लिए कितना heat चाहिए? Let's imagine that 100 degrees Celsius पे the water starts to boil. Now that 100 degrees Celsius is called as latent heat of vaporization. ठीक है? The amount of heat that is required to evaporate any water is called as latent heat of vaporization. Right? Now that 100 degrees Celsius will be latent heat of vaporization. Likewise, latent heat of condensation. Now, what do you mean by condensation? Condensation is nothing but conversion of water vapor into rainfall, precipitation. So for that, this water vapor, which is the heat that is being held by the water vapor, and then the water vapor itself converting into rainfall. Now, in that process, this 19 units are used. Okay? Now, where are these 9 units are used? Convection. देखो, rainfall होने हर एक process. For example, you are sitting here, or if you are walking in this room, there is a heat that is being released from your body. ठीक है? Even if you are taking some breath and giving out breath, that energy is always calculated in the form of respiration. That means आप कुछ ना कुछ काम कर रहे होता हो, heat calculations में calculate किया जाता है. वैसे ही, if you are taking this latent heat of condensation, that means the water which is present on the surface of the earth, it is evaporated. Now that evaporated water, it has to turn itself into a rainfall, right? For that there is certain amount of heat that is required. Now that heat, to give that rainfall, it is called as latent heat of condensation. Not just rainfall, it can be snow, sleet, hail, anything it can be. That is called latent heat of condensation. Now next 9% is utilized in the convection. Right? This is what is called as the heat budget. So, human beings, what we have done is, we have actually increased the carbon dioxide on the surface of the earth by industries that we have generated in the last 200-250 years. इससे पहले इतने industries नहीं थे हमारे पास, because of which today this entire heat budget which is there, it is getting disrupted. Right? So, for example, if you are adding carbon dioxide more, what changes will you take? What changes will take place? Basically, 14 units are absorbed by the atmosphere. Instead of this 14 units, there can be increase in the absorption. And next, this 13 units are there. Sorry, 34 units are there. In fact, these 34 units are being absorbed by the atmosphere itself. So 34 plus 14, how much? 48. That means 48 units of the entire heat that is there, it is actually being absorbed by the atmosphere, and it is always the same. IPCC reports, that is Intergovernmental Panel on the Climate Change, it says that this 48 is going to convert itself into 51 by the year 2100. Yes? 3 यूनिट से 2.5 डिग्री सेल्सियस का फर्क पड़ने वाला है. अब उससे क्या क्या फर्क होगा? What are the changes that you are getting to see? Now those are nothing but which you have learned in the climate change topics. Clear? ये है आपका heat budget. Right? Any doubts here? And see, at some parts of the earth you have surplus heat. Now this, what we have done is we have taken this earth as a single entity. Now earth here, we have taken the earth as a whole entity and we have calculated. But when we look into the earth and break them into tropical latitudes and polar latitudes, it will be like this. If this is your earth, equator, Tropic of Cancer, Tropic of Capricorn, Arctic Circle, Antarctic Circle, the highest amount of heat is actually received between these two latitudes all throughout the year. Right? Now this is where you will see surplus heat. Right? And this part of the earth heat deficit. This is also deficit. Now this is 90, this is also 90, this is North Pole, this is your South Pole, right? This is 66 and half, this is 23 and half, 0, 23 and half south, 66 and half south. Now for NCERT में एक डायग्राम दिया होगा, ठीक है? That diagram, it is nothing but if I am turning this diagram like this, the same diagram, zero. Can I draw it like this? 90 north, 90 south. This is my tropics. ठीक है? So this part of the region will have right? If I am marking my polar latitudes, सरफेस एरिया देखो कितना छोटा है, ट्रॉपिक्स देखो बड़ा है. So in examinations and all, you should draw the diagrams like this. So basically, this is the surplus, heat surplus, and that is heat deficit. In fact, some books, what do they do is instead of mentioning this 20, they'll say 30 and 30. 30 south, 30 north. ठीक है? Instead of 23, they'll say subtropics, क्योंकि subtropics में इतने सारे deserts है. So deserts, they generally take in the heat. So that's why surplus that is there. I also got the NCERT to show this to you. This diagram will be there. They have represented like this. ठीक है? You can also go and look into your notes for online. Yes. So this is the diagram, and your NCERT mentions deficit ko. So it does, what does it do is, it has simply mentioned surplus को दिखाने के लिए. It said that this is surplus heat. ठीक है? And it said it is deficit. So you need not complicate your diagrams and all. Simply you can write like this. ठीक है? Examiner को at the end समझना चाहिए exam में. Right? This is what is deficit and surplus. Now why do you have that deficit is primarily because here, if you look, imagine this is your sun. See, sun rays which are falling, they form either at one or the other point of the time, they fall directly. But here, slanting ways. And you know the logic. Why, in spite of the sunlight reaching the South Pole and North Pole, they do not generate the same amount of heat that is generated at the equator? क्योंकि they cover larger surface area and they cover lesser surface area. क्योंकि same heat is given on a small area and same heat is given on a larger surface area because that rays are slanting, and the other one is shape of the earth. It is geoid. क्योंकि earth, if you broadly look into the literal shape is यहाँ पे flat. ठीक है, this is also flat. Clear? Now this is what is your heat budget of the earth. You know what is conduction, you know what is convection, you know what is radiation, surplus heat. अब आप बताओ सबसे ज्यादा वेजिटेशन कहां पे होगा फिर? In order for you to understand this, you need to think like this. What is the primary source of energy for us? Sun. If there is no sunlight, will you have plants? No. If there are no plants, there are no animals. If there are no animals, then there is a cycle that need to take place that won't take place. So usually the primary productivity means the primary energy which is generated and the energy that is utilized to do the work, primary productivity is very less. Primary productivity मतलब primary producer जो होता है ना, that here productivity which is there is less. ठीक है, इसीलिए देखो वहां पे ना फूल, पत्ते, ग्रास कलरफुल होता है. क्यों? बेसिकली ग्रीन कलर प्लांट्स जो है ना, दे हैव द पिगमेंट्स ऑफ क्लोरोफिल. Chlorophyll, it uses sunlight, and through that, if there is no sunlight, for the survival of those plants, don't you think that those plants should use some other technology and methodology so as to live? So instead of chlorophyll, they'll use different pigments, and that pigments will have different colors, and we like so much. But you need to understand that if the plant is not green, it is an indication that it is using some other technology to survive itself, right? So usually, as you go towards the northern area, Canada and all, US and all, there is a season. In that season, you will see colorful plants coming up. See, that colorful plants are just because they do not have enough sunlight. And the plants do not get enough water. The plants do not get enough sunlight. Because a plant to survive in that such harsh conditions, they have to adapt to one or the other new methodologies to survive them. Right? Likewise, you go to the polar region. ठीक है, polar region और you go to Himachal or excess heights पे जाओ, कौन सा plants दिखता है वहाँ पर? Yes, shrubs are also seen, plus coniferous trees are seen in Himalayas. Now, why coniferous trees there? Because imagine if you have a broad leaf, snow गिरेगा, पत्ता, the leaf cannot withhold that. So it will fall down. So it has adapted to itself to withstand that snow, and it has made to live with the needles. And you know, during the winter they don't grow. Simply they shut down their metabolism activity. And have you ever seen the leaves of the coniferous trees falling down? They don't shed that easily. Very less they'll shed. ठीक है? You know why? If you go near to the polar region, they don't shed their leaves. Tundra, taiga areas. It is because if once they shed their leaves, they have the sunlight only for 3 or 4 months there. And that sunlight is also not intense. Bichara, unko ye lagta hai, I won't shed my leaves, rather I'll mold myself into one or the other way. If I'm shedding my leaves, next year again I have to grow, for which I need sunlight. That sunlight is very less. So that's the reason why those trees which are located near to the polar region, they don't shed their leaves. Only leaf shedding is an activity much you will see up to below 66. And in fact 50 degrees north, 50 degrees south latitudes and all, they don't shed their leaves. Rather, if there is excess amount of snow, they'll turn themselves into a leafless tree with needles. That one of the finest examples is nothing but your coniferous trees. Chir, oak, pine, these trees are there. Go to Himachal, go to the higher regions of the Uttarakhand, that is what you will get to see there. Right? And they have the tendency to store their seeds within the plant itself. Right? Okay. So, and one more component that I have to tell you. You remember this? Everyone? 49, 43, 7. Okay, UPSC is going into these areas also. 7, 43, 49, remember? And infrared, long wave and short wave radiations also. plus, see, you have to understand one thing, that the highest amount of heat which is there is actually being trapped by the greenhouse gases which are present. We should always maintain the balance of the greenhouse gases. If you are not maintaining the balance of the greenhouse gases, the temperature of the earth will definitely get heated, right? Okay, with this we have time. Yes, oh, good time is there. Now we'll go to the next topic. Before that, I want you to write the albedo scale. ठीक है, factual content है, nothing I can do. All you need to do is remember. Albedo scale मतलब the amount of sun's rays which are being received by the earth and it is being reflected. Or else, sun's rays when they are sent to the earth, who reflects more? Fresh snow, 80 to 85% of the sunlight is reflected back. ठीक है? Old snow, 50 to 60. Sand, 20 to 30%. Grass 20 to 25, dry earth 15 to 20, and wet earth 10. Quickly take down this. Dry earth जहाँ पे nothing, no plantations are there. Desert nahi. Desert has high albedo. Comparatively, deserts have high albedo. Dry earth is nothing but a plain earth. And see, this diagram which we have drawn, sometimes few books will write the highest amount of surplus, the highest amount of heat on the earth is present between 40 degrees north and 40 degrees south. Is this statement right? Yes, it is right. So it depends on the author, how the author is looking forward. You always need to mention, sometimes they can write 40 to 40 also. फिर भी this is right. Right? You just need to be using your common sense. मैं 30 लिखा तो कभी कोई author 35 लिख सकता है, कोई author 40 लिख सकता है. But usually anywhere between 40 to 40 सबसे ज़्यादा heat होता है, बाकी areas में heat कम होता है. Quick factual content है, you need to mug it up. Logics, with logical reasoning you will be able to remember this kind of content only after the completion of entire geography. तब कुछ logics लगा सकते हो आप. Of course fresh snow is there, it has high albedo, whereas you see thick clouds 70, thin clouds. Now this you can go for a logic because you already know the concept of clouds, that higher clouds are thin, so their albedo is only 25 to 50. That means albedo in literal terms is how much are they reflecting back? Reflection. So higher clouds, they reflect less. That means they can easily let the heat pass through. Thick clouds, lower clouds hoga 70 to 80. Water, 3 to 5%. There's no albedo. That means water is actually absorbing the heat. And you know, water has more specific heat. देखो, to heat 1 kg of water and to heat 1 kg of land, who needs more heat? Sorry. To raise the temperature of the water, 1 kg of water by 1 degree Celsius, and on the other side you have a land, you wanted to raise 1 degree Celsius of temperature. Who needs more amount of heat to raise 1 degree Celsius? That is called specific heat. ठीक है? It is water. Because write down this, I'll explain. Once you are done, let me know. हो गया? Online done? पूरा off? Okay. My question was, this is water, ठीक है? And this is a brick, right? I wanted to raise the temperature of this water by 1 degree Celsius and same 1 degree Celsius of this brick. I asked you a question, if I am giving heat, who needs more heat to raise their temperature by 1 degree Celsius? Right? Many of you said land, but the actual answer is water. Now why water and why not brick? It is because if you are continuously giving heat to this, and here also you are supplying the heat, who can move and who cannot move? Water can move. Can the solid rock move? No. Why it cannot move? Because in the solid rock, the molecules are tightly packed. ठीक है? As they are tightly packed, the conduction is very quick. But for water, you need to do convection. समझ गया? आप अगर इस पानी को गर्म किया यहाँ पर, क्या होता है? ये पानी इट विल स्टार्ट टू राइज और ये दोबारा घूम फिर कर आएगा, है ना? दिस इज मेकिंग ए सेल. कभी चाय उबालते वक्त देखा? इट मेक्स सर्कल्स, राइट? 10 सर्कल्स आर नथिंग बट योर कन्वेक्शनल करंट्स. कन्वेक्शनल प्राइमरीली यहां पे भी कंडक्शन होता है, बट द प्राइमरी प्रोसेस थ्रू विच द हीट टेक्स प्लेस इज थ्रू कन्वेक्शन. क्या? दो, इसीलिए मूवमेंट इज इजी. ठीक है? Because the heat is given from all the sides. If you are pinpointedly giving from one particular area, convectional sense, see, it can not just have 2, it can have 100 also. It depends on the size of the ball. I think we need not go into this, but primarily what I am trying to tell you is, here the water can move, the heat is distributed. So that's why to heat this water by 1 degree Celsius, it needs more heat and it needs less heat. And this concept is called as specific heat. The specific heat of water is more as compared to specific heat of land. ठीक है? Instead of this brick, now you consider this as a land and this as ocean. Right? So now let's try to understand factors that influence the distribution of temperature on the surface of the earth. ठीक है? So आप बताओ कौन सा ऐसा फैक्टर्स है विच एक्चुअली इन्फ्लुएंस द डिस्ट्रीब्यूशन ऑफ टेम्परेचर ऑन द सरफेस ऑफ द अर्थ? एल्टीट्यूड, वेरी गुड, क्योंकि आपने लैप्स रेट पढ़ लिया ऑलरेडी. ठीक है? ही सेड सर इट इज एल्टीट्यूड, वेरी गुड. एल्बिडो, ठीक है, एल्बिडो कम्स लिटिल लेटर. आई विल ऑल्सो एक्सेप्ट एल्बिडो. Albedo I'll consider last. ठीक है? Next. Distance from the sea. क्यों? Distance from the sea. Distance from the sea is also a factor, but I have to explain you. Next, winds, ठीक है, but more than winds, another biggest factor which you are missing out is latitude. So look here. First one is altitude. As you already know, the concept of lapse rate, I don't think I need to get into this particular area, right? आप सबको पता है why with respect to height, if you are rising, why the temperatures are getting reduced. Why? Why the temperatures are getting reduced as we go higher into the troposphere? आंसर ऐसे करना है, मुझे पता है आप सबको पता है, बट यू नीड टू टेल दैट द हीट, मेजॉरिटी ऑफ द हीट दैट इज गिवन टू द एटमोस्फियर इज फ्रॉम द अर्थ्स outgoing terrestrial radiation. So therefore, the lower regions of the earth which are there, they get heat first through the process of conduction, right? So whatever you have thought is right. So मैंने बताया था, much of the heat which is there, if you broadly look into, 14 units are given through what? By the incoming solar radiation, by the sun's heat. 34 units are given by who is giving more heat? Earth is the one which is getting more heat. Aaj is, when you go out today and you look, the temperatures are very hot, 46 it is, 44 it is. In that, 14% contribution is through the sun. The rest of the contribution of that heat is by the earth. Because we have learnt on the day 1 or 2 that seasons, March 21st, June 21st, ठीक है? As and when you go towards the 21st of the June month, that is the day, just the highest heat that you will receive on that day. ठीक है? Because of the positions of the earth and the sun. Okay. Altitude factor, you know. Next is distance from the sea. See, the primary reason why the distance from the sea will influence the distribution of temperature is because land takes less amount of time to heat and it also cools quickly. Land जो है, it cools quickly and it heats quickly. Because you have seen this. Who is getting heated fast? Land. It is taking time. So when the sunlight is given to both of these particular areas, who will heat fast? Land will heat fast and water will not heat. And who will lose the heat fast? Again land. This will lose the heat little slowly. So what happens when you are sitting next to the sea is that during the daytime, the land gets heated very quickly. वैसे water is also getting heated. But even before the water is cooled at night time, the land is cooled at a faster rate. ठीक है? That's why you go and sit next to the beach. You will understand that morning time, the winds are coming from sea to you, and night time, if you are facing the sea and standing, the wind will be moving in opposite direction. Land breeze and sea breeze. ठीक है? This concept I'll explain tomorrow. For that I need to explain what is low pressure, what is high pressure. That you don't know till now what is the concept of low pressure and high pressure, because that itself will take good amount of time. And the other factors are clouds. You already know the concept of clouds, we have discussed, right? Next is latitude. Latitude will obviously influence the distribution of temperature. Number one, if you are living near to the polar region, you won't have high temperatures. If you are living beyond 23.5 degrees Celsius, the winters will be cold and the summers will be hot, right? So that's why latitude also. Even on the same latitude, just imagine on the same latitude I'm talking about, if you have a mountainous area and if you have a plain area, will the temperatures be same? No. That means altitude is impacting, right? So Mount Everest, it is south of Delhi, you know that? Latitude अगर देखा जाए, Mount Everest is present south of Delhi, latitudinally. But why is that Mount Everest is having minus 30 degrees Celsius? Because of altitude. But Delhi having too much of high temperature because of the latitude, that is too high temperatures, direct sunlight. And the last one is albedo. If the surface of an area is having covered with snow, it has high albedo. Likewise, it is having covered with thick clouds. This will also impact. So majorly these are the factors that are influencing the surface of the earth, distribution temperature. So you should not study this independently. Sometimes an area, when you look, kuch area it can be plain on the same latitude, it can have a mountainous area. Now the characteristics of these areas can be different. At times one factor can influence more, at times another factor can influence more than the other factor. You should be studying it in a holistic terms. Individual silos mein nahi padna hai. When you start to look the geography subject through a silo means only through one factor. Imagine if I said the 23 degrees latitude will have high temperatures, right? Then you will think that there is also areas in Africa which are there in 23.5 degrees which have cold temperature. Then you should not think that, sir, यहाँ पे तो cold temperature होना ही होना है. नहीं, वहाँ पे height increase हो सकता है. So height can be a factor. You have to always consider all the factors, right? So let's look into Chandigarh. Chandigarh, it has high humidity. Can anyone tell me why? Chandigarh has very high humidity as compared to other cities in the same latitude. You know why? Because Chandigarh is covered with three sides mountains. ठीक है? Majorly. And it is a little plain area. So the heat that is there here, it will not get distributed. You go to Dehradun. There also the humidity is very high. Because पहाड़ है दोनों साइड, बीच में plain area. So यहाँ पे जो evaporation होगा, that mountains will not let the wind to move properly, and the circulation of the wind is not proper. So because of that, the air that is there, it gets trapped there. So every city has its own challenges. Every city has its own topography. Chennai gets floods in the month of December. Now why? When you learn monsoons, you will get to know. Because west of Chennai, that is western part of Tamil Nadu, it has very big mountains that will not let the air to come onto Chennai during the months of June. So these are some things that we are going to venture into the next class. So before that, I will be introducing a small concept, the concept of high pressure and low pressure. Now this is what is the mother of all geographical concepts. If you understand this, you'll understand the rest of the subjects. So the concept of high pressure and low pressure. See, how many of you are from science background? 1, 2, 3, 4. Physical geography is different from physics. ठीक है? You should not look this geography through physics angle. The day when you start to look, your concepts हिल जाएगा पूरा. Right? You have to understand one thing. When you have to understand the concept of high pressure and low pressure, let me tell you the relationship between temperature and pressure. Can anyone tell me? जहां टेम्परेचर ज्यादा होगा वहां पे प्रेशर ज्यादा होगा या कम होगा? यस, it is low. When you have high temperature, your pressure is low. This is true at the surface. ठीक है? This is true at the surface. This is not true when you go to 8 to 10 kilometers above the surface of the earth. Right? So let me first explain you the concepts of the relationship between temperature and pressure. Now for that, let me take a packet of air. Imagine this is a packet of air, and the temperature of this packet of air is 10 degrees Celsius. Right? What I have done is I wanted to give heat to this, and raise the temperature to 25 degrees Celsius. What happens to the packet of air? The packet of air will expand. Right? Now the molecules of the air, let's see. What does we do is, let's make some units in this particular packet. Units मतलब समझते हो ना सब? How many units are there in this? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. How much? 24 units. Right? In one of this unit, I'll put the total air molecules which are there. How many? 1, 2, 3, 4, 5, 6, 7. What I've done is I've put 7 air molecules in one unit of the packet of air. So I have decided that I'm going to rise the temperature of this particular packet of air. What happens? The packet of the air size increases. Right? So in other words, in this area there are 7 people sitting in this unit. So same way, right? So when I've increased the temperature, when I've raised the temperature, currently this temperature is 25 degrees Celsius. Now here also, just imagine there are 7 units, 7 people, 3, 4, 5, 6, 7. Who can move more freely? The one who is here. Who is having more pressure? Okay? In the case of A. In the case of B, the pressure is less, so that they can move easily. So imagine this is your air. Okay? The molecules of air, whenever their temperature is increased, the packet of the air size increases and the molecules can easily move. Right? And they experience less pressure. But here, jagah kam hai, udhar hi move karna hai. So that's the reason why they experience high pressure. Now what is the temperature here? So temperature, is it comparatively high or low? Low temperature. Pressure? Now same thing. What is the temperature here? What is the pressure here? Low. This is the logic that you need to remember whenever I'm using a high temperature. That means you need to think that वहाँ पे low pressure होगा. Right? If you have less temperature, you'll have low pressure. Right? So see here. This is your equator, 0 degrees, and this is 23, 66. Who will have, all throughout the year, who will have more amount of heat? I'm talking about between equator and 23. Who will have more amount of heat? Will equator have more heat or 23.5 degrees north? चलो, ऐसे समझ लेते. For 3 months, you will have summer and 3 months you will have winter. What is the temperature during the summer here? 45 तक जाएगा. Winter में 10-12 degrees. What will be the average? 40 plus 40 and 10 का average निकालो. Yes, 25 degrees Celsius. The average temperature, if you look into, it is 22 to 25 degrees Celsius. I'm talking about all throughout the year. Equator, irrespective of summer, winter, whatever the season, summer में it will have 45 degrees Celsius, winter में it have 35 degrees Celsius. What is the average? 70 divided 80 divided by 2. That means average temperature is near about 35 degrees to 45 degrees. Right? Now, can I call this as an area which is having high temperature area? As compared to this area, will this area have high temperature or low temperature all throughout the year? Average, if I take low temperature. Low temperature, high temperature. Now, who will have low pressure? As per the analogy that we have learned, this is now what is this? Right? This is low pressure, this is high pressure. Clear? Likewise, if you are following a particular latitude and trying to understand what kind of pressure you will have, if you study this as a belt, this belt is called as pressure belt. Now, this is equator. Equator के पास ज़्यादा temperature है, and it is having low pressure, high temperature. So, can I call this belt as equatorial low pressure belt? Yes or no? I'll call this as equatorial low pressure belt. Can I call this as subtropical region? What is subtropics? 20 to 30. Can I call it as subtropical high pressure belt? Because across the latitudes, if you look into, this is subtropical, which is having high pressure, and this belt is called as subtropical high pressure belt. Right? देखो, this is also the same case for the entire belt. ये ऐसे घूम के है, it is like this. हाँ, doldrum region जो है ना, वो यही region है. I'll explain that little later. यहाँ तक clear है? Now let's try to understand what happens in the low pressure and what happens in the high pressure. Right? So, likewise, your earth will have multiple pressure belts. If you look into this earth, your earth has one. At equator, you have a low pressure belt. And at subtropics, you have a high pressure belt. You will have a high pressure belt here. Again, you will have a high pressure belt here. Surprisingly, you will have again low pressure belt here. Again low pressure belt here. And then polar region you will have high pressure. ठीक है? This belt near to the polar regions, you will comparatively this will have more temperature as compared to this. Do you agree? This particular area, subpolar region, 66.5 in the south, will it have more temperature as compared to this? हमेशा जो high pressure और low pressure है ना, comparatively देखा जाता है. How do you say you have high pressure here? You have to compare to someone or the other, right? Now, if I am comparing with someone else, I can be a low pressure to that fellow. If I am comparing to this fellow, I can be a high pressure to that low pressure. They are always comparative, right? And see, this pressure is always measured in isobars. ठीक है? Pressure is always measured in isobars. Isobars जैसे और millibars. ठीक है? Millibars is the pressure units. For suppose I have places that are having equal pressure. ठीक है? And if I am going to join all the equal points, that line is called as isobar. Now for that, let me show you. Let's go to India. I'm going to mark few points. Sorry. Imagine these points are having equal pressure. I'll call this as 1000 millibars. दिस इज ऑल्सो 1000 मिलीबार्स, ठीक है, यहां पर भी 1000 मिलीबार्स का प्रेशर है. All the points here, yellow points are 1000 millibars. If I am joining these lines, now what is this line called? Isobar, an isobar of 1000 millibars. Similarly, if this is 998 millibar, if I am joining these millibars, these millibars, now this is, what is isobar of this particular line? 998 isobar. Now who is having more pressure? 1000 or 998? 1000. हमेशा ये याद रखना, wind always moves from high pressure to low pressure. Right? Clear? So wind will start to move like this. This is high pressure, right? And this is low pressure. Wind will move like this. Now I'll create one more low pressure zone here. Let's imagine this is 990. Right? So I'm joining these lines. Or I'll create one more, and this is 900, right? So wind always moves from high pressure to low pressure. So ये low pressure area है ना, तो अगर सारा हवा यहाँ पे आ रहा है, don't you think that that particular area should be full of air? And if the air is moving out from this place, don't you think that there shouldn't be any air that is left there? That shouldn't be any air. लेकिन ऐसा होता नहीं है. ये देखो क्या हो रहा है यहां पर. The wind starts to move in. The wind ultimate aim is, the movement of the wind is always from high pressure to low pressure. All the wind will come and rush to this place. ठीक है? If the wind is rushing to this place, now what happens is that the wind which has come here, it will start to rise. ठीक है? I hope everyone got to understand this. All the wind, let's imagine this is the indoor, Madhya Pradesh मान के चलो. Madhya Pradesh indoor में there is low pressure system that is developed. Very, very low pressure is there, 960 millibars, and rest of the area is having high. So the wind will start to rush to the indoor, and in the indoor, the wind starts to rise upward. ठीक है? This wind which have risen, it will reach till the height of the tropopause, and then it diverges. ठीक है? समझ गया? So it is like this. Suppose if I am having a low pressure area, the wind will start to come from all the directions. Why? Why is it coming? Because comparatively you have a high pressure in all of the other areas. ये सब areas high pressure है. Now once they come, from here on, they will start to they'll rise. Imagine this is tropopause. Once the air that is risen, what does it do is, right? Continuously the air is rising and the air gets diverged. It's like this. हाँ, temperature के हिसाब से ही होता है divergence. Now this air which is diverged, it will again come and sink at high pressure area. ठीक है? It will sink and it will move like this. Right? So imagine if there is low temperature, low pressure, what is the temperature? High temperature, let's imagine this is indoor. Indoor mein temperature is 45 degrees Celsius. ठीक है, this is 45 degrees Celsius of temperature is there, and this is at a height of 8 kilometers. What will be the temperature? कम होगा, माइनस में होगा. Now माइनस में, if there is low pressure here, what kind of pressure it should be there? यहाँ पे टेम्परेचर कम है ना, राइट? बट फिर भी यहाँ पे ना इससे भी लो प्रेशर होता है, ठीक है? द कॉन्सेप्ट दैट आई हैव एक्सप्लेन्ड यू विथ रेस्पेक्ट टू लो प्रेशर is only confined to the surface. I'll tell you in the next class. Hopefully it is tomorrow is Saturday, right? Saturday. So Saturday is your discussion session. अगर आपको कोई भी doubts है, online people will have a call, and offline अगर आप you go and read. If you have any doubts, we'll have one-on-one sessions. All the doubts will be cleared. You can come. I'll be available here itself. We'll sit and we'll discuss. I'll address you personally if you have any doubts, right? So here the temperature is somewhere around minus 20 degrees Celsius होगा, but फिर भी the pressure here as compared to this point will be low. ठीक है, as compared to this pressure will be low. Remember this very clearly. The concept that I've explained, the relationship between temperature and pressure, is true only at the surface, not here. Right? Why? I'll tell you in the next class. ठीक है? It is Monday. So this is something which you need to understand, and I'll give you a more elaborated explanation on this. What is high pressure, what is low pressure, how the wind in the high pressure works, how the wind in the low pressure works. And here, anything that is moving in the atmosphere on the water, that will experience a force called Coriolis force. ठीक है? Coriolis force is a force. If suppose an aeroplane which is moving, if it wants to move from India, ठीक है, let's imagine an aeroplane which wants to move from India, which is Chennai, ठीक है, from Chennai, this aeroplane wants to go to a place called Ulaanbaatar, or else maybe Kazakhstan, Astana, capital city है, ठीक है? So if suppose this aeroplane has started to move, what is the speed of the aeroplane? 800, 900 kilometers per hour it goes. But what is the speed of the earth? It is more faster. You know that the earth rotates. ठीक है? By the time if the aeroplane wants to move here, by this time the earth has changed its position. Right? There is a deflection, right? This deflection is towards the, if anything which is moving, it deflects towards the right in the northern hemisphere, and anything which is moving in the southern hemisphere, it deflects towards the left. This I'll explain in the next class. For you to understand this, what you need to do is tilt the earth like this. Now see, earth rotates from west to east like this. Now you start to look from the north pole. Earth rotates in clockwise or anti-clockwise? Your clock rotates like this, but your earth is rotating in anti-clockwise. Imagine from this point A, you wanted to go to point B. While you are moving, the earth might have shifted, this point B might have shifted somewhere here. Right? So this is nothing but the deflection. So a wind which wants to move from A to B, if it wants to go to A to B, but it will never reach B, it will get deflected. This deflection is called Coriolis force. Any wind which is moving on the surface of the earth, it will experience Coriolis force. Aeroplane, wind, rocket, even the birds which are flying, birds know the Coriolis force very well. Water which is moving experiences Coriolis force. All that is moving in the air will tilt towards right in the northern hemisphere, towards the left in the southern hemisphere. Right? So it will be like this. Suppose, imagine the wind is moving in this direction from all the sides. What is the deflection side? In which direction is the deflection? this wind will start to deflect towards its right. एंटी-क्लॉकवाइज. ठीक है. हाँ, ये अभी it will take some time for you to understand this Coriolis force because I have to explain you in detail. तो ये सब हम अगले क्लास में करेंगे. Right? Now, please make sure to read the NCERT. I want you to read the chapters, complete the climatology in detail. जो chapter number 9, 10, 11, 12 है, पढ़ के आना. Sunday है, बहुत time है. Saturday है, बहुत time है. And later on we'll move the pace. अब तक I'm going very slow. This is a democratic classroom. It's been 5 days to our, this is the class. In the 5 days, on day 1 I have given introduction, day 2, day 3, day 4 I have given very, very basics to you. But the time has come, now we are going to take off. Right? Yes? Fast लग रहा है? Will slow जाना है? Is the speed fine? ठीक है. समझ में आ रहा है कि नहीं? This is logical subject. एक बार समझ में आया तो you need not worry about this subject. This subject will give you how many questions you know. Geography plus environment. If you add current affairs of geography and environment plus 3 more questions. 33 questions. Out of this 33, you at least make 25 questions right. This 25 questions, if you are making it right, 50 मार्क मिलता है प्रीलिम्स में. ये अकेले सब्जेक्ट, दिस सिंगल सब्जेक्ट कैन गेट यू आउट ऑफ दैट प्रीलिम्स फियर. राइट? दिस 25 into 2, 50 मार्क्स. नाउ गो एंड रीड योर हिस्ट्री, एंशंट, डांस विद एंशंट हिस्ट्री, आर्ट एंड कल्चर पढ़ लो, कुछ भी कर लो. ठीक है? वहाँ पे ना 10-12 से ऊपर नहीं मिलेगा मार्क्स. This subject is a bridge for all other subjects. You'll write essays well. You'll also write beautiful introductions. By the time when we reach the human geography, you'll be awed. Means you'll be falling in love with the subject. Human geography, up tak we are trying to learn the basics. Now try to put a human being in a low pressure area. Try to put a house in a low pressure area. Try to put plantations in that low pressure area. I told you, surplus amount of heat is there in the tropics. Now think of a farmer who is living in that area. A farmer who is living in the non-surplus heat area, he always has to live on what kind of crops? I told you, I gave you a small homework. What are the night, जहाँ पे crops that are grown in the night time? Rice. Rice is always grown in the night time. Daytime it sheds itself. Right? Coffee is there. Mountainous area. Coffee. Why is tea grown in Assam? Why is coffee grown in Karnataka? Right? Why the floods in Chennai are only in the month of November, December? Now, the constructions that are there in Delhi, what is it? I told you in Chandigarh, why is the 2-floor ceiling is there? Current affairs, today in Chandigarh, you are not in a position to sell one single floor to anyone. The government has put a ban. If you want to sell your house, you have to sell your entire house, not just one floor to another person. Geography. It is because population hai, they wanted to lock this population and they don't want anyone else. Now, think of the comparisons between Chandigarh and Delhi. In Chandigarh, all the roads are cross, like rectangle, round chalta hai. But go to Delhi, the roads are hexagonal. They are like this. The junctions are not round. In Chandigarh, all the roads will come and join like this, right? But in Delhi, the roads are like this. Why? Hexagonal, mitti. Delhi में इतना dust storms होता है. If the circles are there, the dust will accumulate in this part of the area. If you are having your houses here, the dust gets accumulated here. But here, the dust will not get accumulated that easily. The plantations are made like this. You come to Chandigarh, the plantations are made in such a way, you look into the march. The march fall is there. The plantations are made in such a way that today Chandigarh is actually giving the manure towards the nearby areas. The amount of leaf litter which is being there, administration is collecting it and still it is giving it to the farmers and it is making money on it. That is human geography. सो एग्जाम्पल्स करंट अफेयर से ढूंढ के निकालना होगा, ठीक है. Recently I have read an article says that the birds are getting extinct. Near about 66% of the birds in the last 60 years have been extinct. So somewhere in southern parts of India, someone who was going to attend the funerals, what happens is that there the significance for the birds are very high. They offer some kind of food after their at the funeral place. They expect that the bird comes and eats it. But today, the food habits of the birds have changed, and the sentiments of the people who are living in that area are being hurt because they believe that their ancestors are not coming and eating the food that is being served. Now this is called cultural geography. ठीक है, कहीं ना कहीं temperatures increase हो रहा है just because you created an industry and you wanted to buy a fancy clothing and a fancy shoes, because of which it has increased the temperatures and somehow it has hurt your cultures. So ये holistic understanding चाहिए. Down the line, 20 more days, you will be in a comfortable position to handle any kind of content that is there with you. You will link up. That I will make sure that you will do it. ठीक है, essays में भी include करते हो, answers में भी introduction, body, conclusions, that I will do it. But I want a promise, ये जो छोटू बुक है ना, दिखने में छोटा लगता है but लेकिन है नहीं. I always say that those who have written, they have written after having their 2 pegs down. ठीक है, they made it so complicated, this book. But the concepts in geography are so easy. So please finish this book as early as possible. I want you to read these climatology chapters by Monday and come back. Then मजा आएगा पढ़ने में. फिर नहीं तो Greek, Roman, alien जैसा लगेगा. Okay, we'll stop here and we'll continue on Monday. Right? If there is a class tomorrow, you will be informed in the group. Right? And if there is no class, it is an indication that it is a doubt session. You can come to me and we can discuss. I'll be available all day here. Thank you. Online. Munindra, just drop a message to me. Number. Note it down. I'll shut the class. Thank you.